Mathematics is one of the courses that, in order to understand math and equations and so forth, you have to understand how to deal with numbers and variables. And in the 8th and ninth grade is where you learn that. And a lot of times, teachers don't go over this in class. And if they do go over it, you overlook it because it's boring. Okay, but if you don't understand how to operate with numbers or number operations, there's no way in this world or any other that you're going to learn how to deal with mathematics and algebra. And algebra uses the arithmetic you learn from 1st through 7th grade. And it shows you how to operate with those numbers. It shows you number operations, okay? So usually your teacher will tell you, your instructor in high school, that will say, read chapter so-and-so, the input to this chapter. And this is where this number operation is located. And they may go over this in class the next morning, but you didn't read it, and most of the time when you get to class, you're not taking notes on it because it's quick. It's very simple and it's quick, so you think you can understand it or remember it. And you can't. You have to study this. You have to, when I say study, I mean you have to do it with your hands. You can't just read it. You have to go through these operations and do it. And if you don't, you'll never learn it. And it's no different than baking a cake. If you decide to bake a cake without reading the instructions, the cake is not going to come out like the instructions say it should come out. Or if you read too fast through the instructions and don't have a few experimental runs with it, you're not going to bake the cake as the instruction says. So that's what you have to do. When I say study, I mean do it yourself. Walk through the operations with a pen and paper. Okay? And that's what study means in mathematics. Doesn't mean just read it. It means do it for yourself until it gets embedded in you. Okay? Okay. You'll see to the left here, I have located onto the left, I have operations here. Okay? And these operations show you how to deal with exponents. Okay, and let's first talk about these exponents. I have here a raised to the power of some number. Okay, and a is equal to the base. Okay, and m is equal to the exponent. Okay, exponent. All right. So a is the base and m is the exponent. So in this first one here, I have exponent, I have base a raised to the power of m times base a raised to the power of n. Okay? And when you have that and the bases are the same, you can add the exponents. So you have a times m plus n. Okay? You can add the exponents. For example, okay, if I have x raised to the power of 3 times x raised to the power of 2, that's equal to x raised to the power of 3 plus 2 is equal to x raised to the power of 5. That's what that means. If I have as my base 2 raised to the power of x, and I have my base 2 raised to the power of 3, then the bases are the same, so I can say x2 is raised to the power of x plus 3. Okay? Now you can't add x and 3 because you don't know what x is, so you say x plus 3. Okay? If I have, let's say, the base of 2 raised to the power of x times the base of 3 raised to the power of x, I have 2 raised to the power of x times 3 raised to the power of x. Okay, and I can't add them because the bases are different. Okay, so that's what all I can say is 2 raised to the power of x times 3 raised to the power of x. I can't add them. Okay, if I have 3 raised to the power of x times 2 raised to the power of y, then I have 3 raised to the power of x times 2 raised to the power of y. Okay, I can't add them because the bases are different. And that's whenever you have bases. If you have x raised to the power of 2 times y raised to the power of 2, let's say put it 2, all you have is x raised to the power of 2 times y raised to the power of 2, because the bases are different. Okay, if the bases were the same, then you can add the exponents. That's what that first operation means. So let me erase this. Okay, so now let's talk about this second operation here. Okay, what the second operation means is that it has one base raised to a power, and then that's raised to a power. So let's see what that does. That means 2 raised to the power of 2, and then that's raised to a power. Okay, so in algebra, what you do is you take, in order of operations, you take care of what's in the parentheses first. So we have, in the parentheses, we have 2 raised to the power of 2, which is 2 squared, which is 2 times 2 is 4, raised to the power of 2, the outside power. Okay, and then 4 squared is 16. Okay, that's all that means. Okay, so let's say we have 1 over x squared raised to the power of 2. Okay, what that means is, within the parentheses, we have 1 squared divided by x squared squared. Okay, that outside square squares a 1 because there's nothing inside the parentheses to do. So we just have the x squared there. So the square takes care of everything in the parentheses. 1 squared is 1. Okay, and x squared, well, this operation is this operation. This operation below on the x squared squared is the same as this operation right here. So we'll have x squared, and that's 2 times 2 is 4. Okay, and that's what that operation is, right? The second operation. Okay. Now, I want to give you one more thing, but I better not do that to confuse you. Okay. So let's look at this operation, the third operation. The third operation is a times b raised to the power of m. Okay, that's 2 times x, a and b are different, raised to the power of 2. Okay, that means this 2 squares everything inside the parentheses. So that means 2 squared times x squared. Okay, and that's equal to 2 times 2 is 4, because 2 squared is equal to 4, and x squared is equal to x squared. Okay, and if you want to rewrite that, you can rewrite that as 2 squared times x squared, and you can pull the square out and say 2 times x squared. Okay, and you squaring everything inside there, and that's equal to 4x squared. You square everything in there, and that's how you perform those operations. Okay, and the same with the third. Okay, you have x divided by 2 cubed. Okay, well, the cube cubes everything inside the parentheses. So you have x cubed divided by 2 cubed. Okay, and 2 cubed is what? 8. 2 times 2, 2 cubed is equal to 2 times 2 times 2. And that's equal to x cubed divided by 8. Okay? Now, perform the same operation here. Let's do that this way on the third, on this, the fifth operation. Let's say we have x divided by y cubed. Well, no, I better not do y because that's let me erase this and do the because it's showing A and B, so A and A. So let's say 2. So it says 2 raised to the power of 3 divided by 2 raised to the power of 2. Okay, where m is greater than n, and this is m and this is n. So that's equal to 2 raised to the power of 3 times 2 raised to the power of minus 2. Okay, and then that's equal to 2 raised to the power of 3 minus 2 is equal to 2 raised to the power of 1, which is equal to 2. What I did was, when I have a power in the numerator, let's say 2 raised to the power of 2, I can move that power up to the top by changing the sign on it. If I move it above the division sign, I can say 2 raised to the power of minus 2. That's equal to 1 over 2 raised to the power of 2. That's the same thing, same number. Okay? So let me erase some of this. Okay? And we'll take this last operation here. Okay, the last operation is 2 raised to the power of 5 divided by 2 raised to the power of 3. And that's equal to, well, I shouldn't have done it that way, because let me do it this way. That's equal to, I'll move this power down. That'll be 1 over 2 raised to the power of 3 times 2 raised to the power of minus 5. And that's equal to 1 over 2 raised to the power of 3 minus 5 is equal to 1 over the power of 2 raised to the power of minus 2. And that's equal to, move that up to the top to change the sign, squared, and that's equal to 4. Okay, now let me do it the way it's written here, where m is less than n. So it has 2 raised to the power of 3 divided by 2 raised to the power of 5 is equal to 1 over 2 raised to the power of 5 times 2 raised to the power of minus 3 because I moved the minus 3 down below the division sign. So now I can add those. Is equal, because the bases are the same, I can say 2 raised to the power of 5 minus 3 is equal to 1 over 2 raised to the power of 2 is equal to 1 over 4. Okay? And that's this right here. And whatever is in the numerator is not 0. Okay? You can't have a equals 0. Okay? So whatever's in the numerator can't be 0. It can't be 2 raised to the power of 3 divided by 3 raised to the power of 0 raised to the power of 5, because that's can't 0 raised to the power of 5 is 0. So you'll have 2/3 2 raised to the power of 3 divided by 0, and you can't have that. That's an illegal operation. Okay? So let's define a to the power of 0 is equal to 1. Okay? So why do we know that? Well, let's have a. Let me erase this and start from the beginning on this a that equals 0. Let me explain that. Okay. So we have 2 to the power of 3 divided by 2 to the power of 3. Okay, and let's go through our operations here. Well, 2 to the power of 3, and we have divided by 2 to the power of 3, so we can move 2 to the power of 3 to the top times 2 to the power of minus 3. Okay, and that's equal to, the bases are the same, so we can have 2 to the power of 3 minus 3, which is equal to 2 to the power of 0. And 2 to the power of 0 is equal to what? 1. Okay? Okay. How do we know that? Well, 2 to the power of 3 is equal to what? 8. Right? That's equal to, let me do it this way. 2 to the power of 3 is 2 times 2 times 2. Divided by 2 to the power of 3 is equal to 2 times 2 times 2. And that's equal to what? 2 goes into 1 time, 2 goes into 1 time, and 2 goes into 1 time, as 1 time 1 time 1 is equal to what? 1. 2 goes into 1 time, 2 goes into 1 time, and 2 goes into 1 time. 1 time 1 is 1. So that's 1 over 1, and that's equal to what? 1. So therefore, 2 to the 0 is equal to 1. Okay? So that's what's cute about that in mathematics. So when you see x to the 4th divided by x to the 4th, well, you know that's equal to 1. Okay? Because that's x to the 4th minus x to the 4th. And that's equal to x to the 0. And that's equal to 1. Okay? So you just cancel these out. And that's equal to 1. Okay, so suppose we had y to the 5th times x to the 3rd divided by x cubed times x to the 4th. Okay? Well, we would have, let's say, we would have y to the 5th times x cubed. Well, hold on, something happened here. Let me erase that. Okay. Times x cubed bring the x cubed from the denominator to the numerator. We have times x to the minus cubed. Leave the denominator with x to the fourth in the bottom. So that's equal to y to the fifth times x to the cube minus cubed, x to the cube, divided by x to the fourth. That's equal to y to the fifth times x to the 0 divided by x to the fourth. And that's equal to y to the fifth divided by x to the fourth. Okay? And that's what you end up with. Now, essentially what you did was, in your initial operation, you had y to the fifth times x cubed divided by x cubed times x to the fourth. Well, we already said that x to the 0 is 1, right? So we can, x to the cube divided by x to the cube goes into x to the cube one time. Okay? So that's a y to the fifth divided by 1 times x to the fourth. And that's the same answer we got up here. Okay. So you don't have to bring that up, the x cubed up, and subtract them. Usually when you see that, you know x to the cube goes in x to the cube one time. So when you have operations like this, z to the third times y to the fifth times x squared divided by x times y times z. Well, when you bring the z up to the top, that's a minus 1. So that's equal to z squared. One of the z's cancels one of these z's, and it makes it 2. X cancels one of the x squared, that makes it x. And y cancels one of the y's at the top, and makes it y to the 4th. So that's z squared times x times y to the 4th. And that's how you do that operation. Or you can walk through it. But when you see these like that with exponents, you know how it's done now. Okay, let me erase this and show another quick operation here. Let's say we had 2y cubed x to the third times z to the 4th. We have 3y squared times 2x cubed times 3z. Okay? To look at this quickly, we say, well, 2 subtracts from 3 one time, so that's equal to 2y over 3, because the 3 is still there. Okay, times x cubed goes into x cubed one time, so that's equal to 1 divided by 2, and z to the 1, this is 1 power, cancels one of those z's up there, so that's equal to z cubed divided by 3. So that's equal to 2 times y times 1 times z cubed divided by 3 times 2 is 6 times 3 is 18. And that's it. And that's how you do that. And that's the operations for exponents. Okay, the next operation I'm going to do is with radicals. And this is the one that very few high school students learn. And it gives them terrible grades in algebra because they don't understand it. And I'm going to show you how to deal with radicals, okay? And in my next lesson. So study this and work with it. And if you learn how to deal with exponents and radicals, believe me, you will never, ever have a problem with algebra, okay?